everyone, I'm Fangyu Zhu. My preferred English name is Vanessa. Now I'm a sophomore. The name of my application is Biology Mystery Hardy Weinberg Equations. It gives users the fastest way to get answers by simply entering values of given conditions in the question. This topic is about biology honor taught by Ms. Meyers. The problem that is automated by my application is solving Hardy Weinberg equation problems. So now I'm going to show my napkins here. So for the welcome frame, it has 247 lines. And for my input frame, it has 1023 lines. And for my output frame, it has 228 lines. And for my display frequency frame, it has 217 lines. And for my display individual frame, it has 204 lines. And for my warning frame, it has 136 lines. And for the arrow individual limit frame, it has 136 lines also. And for the arrow frequency range frame, it also has like 134 lines. And for my help frame, it has 602 lines. And for my quick converter frame, it has 279 lines. And for my computation class, Hardy Weinberg equation has 442 lines. And for the percent decimal conversion, another computation class also have 58 lines. So let's go show my work here. Just click the husky. So it will be a little slow, but you see just my husky, and also I put in the notes here. So we will get started. So welcome to this fantastic biology math class. Basically, there are two equations that are used in the Hardy Weinberg theorem. One is p plus q equals 1, and another one is square p plus 2pq plus square q equals 1. And buttons you can either to access into input frame or access program. And the menu here you can see we'll use later on. Let's start. So if you are unknown about this equation, you may be a little messy about, so maybe you can get help first. Let's get help. So about us, who made this is basically the basic information about myself and who can use this. Everybody can use this application to help you. And the origin of the Hardy Weinberg. So if you want to know more about this equation, so you actually can read this article and how to use the application. So welcome frame display the brief information, input frame access inputs, output frame pops up in results, display frame display the outside of the data, and help frame gives you help, and warning frame show you the arrows. And all letters represent what? So for the letter P represents frequency of dominant alleles, letter Q represents frequency of recessive alleles, and letter square P means frequency of dominant homozygous genotype, and 2pq means frequency of dominant heterozygous genotype, and square Q represents frequency of recessive homozygous genotype. Yeah, that's biology. So hard. And for the number error explanation, so purpose of the warning frame, the number is if you are not enter a number, it will show arrow. And for this one, why is radio button 4 asking individual not enabled after you click the button 1? Click giving individuals. This is because the question won't be that silly to ask your individuals again after you're already giving individuals. So let's go back to input frame. So I saw a photo, like I got some question from online. So from here, 38% of the individuals are recessive homozygous, and the population of 14,500 and calculate the amount of individuals here. So from analyze the questions, we know the frequency of recessive homozygous, which is square Q, and total populations, and also it's asking individuals. So now we can select the buttons here. It gives the frequency and square Q, right? And also asking individual. But now pay attention to percentage. All calculations here are using decimals, so we can use a quick converter to help us. We know the percentage is 38. We convert. The decimal is 0.38, so now we know that. Select and display. So we select 0.38 and 14500. So calculate this answer here. So we can compare the answer from online and also my calculation here. So my calculation is actually more accurate, and this one is just like rounding answers. So basics mine is more accurate. And now I go back and display the table here. So we did now put the data for the frequency, so we can now get the data. But for individual data, you can see the data here. That's what just the one we did there, and we can just go back and continue add. So I want to show the function of my arrow. Like for example, here asking frequency, and if for frequency and you're in 21, it will show. Dude, for frequency, you should enter double between 0 and 1, so you can go back and re-enter. And for the given individual, like for example, the dominant here. So no matter is it dominant or recessive individual, it should be like always smaller. But if you put X in it like 21 and this one is like 1, they will show the arrow. Dude, your total sample individuals enter must be larger. So you can just go back and re-enter over here. So, and also like if you enter like characters, but critically, dude, give me a valid number also to show the arrow. That's all total my function can do. And so if you want to know more, you just can use this. Thank you for your help, for your listening.